Today we discussed about context-free grammar. Grammar is a mathematical model used to design a software. It is used to identify the syntax of a language. It is used to identify the syntax of a statement. Definition of a grammar. Grammar G can be formally written as a four-tuple B, T, P, S, where B is a set of non-terminals or N is a set of non-terminals. T or summation is a set of terminal symbols. P is a set of rules called production. S is a start symbol. Each production is of the form alpha production beta, where alpha is a non-empty strings of terminals or non-terminals. Beta is a string of terminals or non-terminals including the null string. That is, alpha is a string of B union T clean positive. Beta is a string of B union T clean closure. This grammar is also called as phase structure grammar. Consider the production shown below. S production A C A, C production A C A or B. Here grammar G equal to B T P S. B contains all the uppercase letter. That means the strings that you are going to derived. S comma C is a non-terminal symbols. T equal to A comma B. It means all lowercase letters, special characters, etc. Further, it is not going to derive it. It is a terminal symbol. P equal to S production ACA, C production ACA or B. S is the start symbol. Derivation of grammar. The process of obtaining a string of terminals or non-terminals from the start symbol by applying some production is called derivation. Strings may be derived from other strings using the production in a grammar. Example, let A equal to alpha B gamma B production beta, or the production in the grammar G, where alpha, beta, gamma are strings of terminals, further not able to derive it. A and B are non-terminals. It can be further derived by the strings. Consider the grammar shown below from which any arithmetic expressions can be generated. E production E plus E, E production E minus E, E production E star E, E production E slash E, E production ID. Generate the string id plus id star id by applying this production. E production E plus E. By substituting E id, you get the string id plus E. By applying E star E, get the string id plus E star E. Then by applying EID, you get the string ID plus ID star E. By applying EID, get the derivable string ID plus id star id, further not be derived by any other strings. Chomsky hierarchy, a containment hierarchy of classes of formal languages. So it is divided into four types. Type 0 is known as unrestricted grammar. Type 1 is known as context sensitive grammar. It is accepted by the linear bound automata. Type 2 is nothing but context-free grammar. It's accepted by push-down automata. Type 3 is nothing but regular grammar accepted by finite automata. So type 0 is recognized by Turing machine. For example, type 0 is known as unrestricted grammar. There is no restriction on the grammar rules of these type of languages. These languages is generated by Turing machine. For example, BAA production AA, S production S. Type 1 grammar. This grammar is known as context sensitive grammar. The context sensitive grammar is used to represent the context sensitive language. The rules for the context sensitive grammar is rules of the form: number of symbols on the left hand side must not exceed the number of symbols on the right hand side. More than one symbol on the left hand side of the production rules. Production is in the form of V production T, S production AT, T production XY, A production A. Type 2 grammar is known as context-free grammar. Context-free languages or the languages, it can be represented by the context-free grammar. Yes, A production ABP. A is a single non-terminal and it is a combination of terminals and non-terminals. A production B and B production A. Type 3 grammar is known as regular grammar. Regular languages are those language which can be described using regular expression. These languages can be modeled by NFA or DFA.